Now, Mary Young from Deakin University to speak about the Apollo Marine Park.
Thank you for coming. So I'm going to talk about some work that we're doing in Apollo Marine Park to try to get an understanding of the ecology. So before I started, I just wanted to acknowledge the Eastern Mar people as the traditional guardians of the sea country on which this project was completed, and I pay my respects to their elders past and present and recognize their enduring role as the first scientists whose deep knowledge and care for country continue to guide sustainable stewardship today. So this is a brief outline of what I'm going to be talking about. So in this project, the main purpose was to build ecological knowledge within Apollo Marine Park. This is a Commonwealth Marine Park, and there wasn't a lot known about it. So it's just getting that basic baseline knowledge so that we can track through time and see if there's changes with climate change. So we developed habitat maps, assessed fish communities, assessed lobster habitat, and then also as part of this project, we're working with the Eastern Mar to assess the cultural importance of the Apollo Marine Park and their broader sea country. So this is some imagery of the seafloor data that we collected at Apollo Marine Park. And usually when we go into a new area, this is the first thing we do. It gives you a lot of information about what's on the ocean floor and allows us to target our surveys. So this is located off of Cape Otway, and these are some of the deep reefs. This is our boat that we take out there, and we have a multi-beam sonar system on it, and then we just drive. We call it mowing the lawn. Just go back and forth for days and collect data on the seafloor habitat. So that's what our computer system looks like inside the boat, and that's our multi-beam sonar. So since this video was created, we've collected more data. And so we also found the first American ship to be sunk during World War II, the city of Rayville. And so that's some of the multi-beam data that we can use. And then I'll show you more images because seafloor is my favorite. So this is the type of data we get out of the multi-beam system. It uses sound, and it sends sound out from the sonar, bounces back, and you can get both information on depth and relief, which is shown on the right-hand side. So the warmer colors are shallower, it gets cooler as you go deeper. And then on the left is backscatter, and that's the intensity of the return, so how loud the sound is coming back. And that gives us information about what the substrate is, so whether it's rock or sediment or some mix. So after we collected that data, we wanted to go see what was actually down on the seafloor. So we worked with the University of Sydney to take out these underwater robots called autonomous underwater vehicles and ran track lines you can see in this image on the right so that we could get a good representation of the different habitats throughout Apollo Marine Park. And so these are some of the imagery that came back. So you can see the different types of substrates and habitats. So we have these really amazing sponge reefs, and then these sediment patterns, and then just some really high relief areas, and then some sponge habitat interspersed with sediment. And we went through, well, my PhD student went through and classified all of those images for us. And so we got a good idea of what's down there, and you can see that in that plot there. Mostly pink is sand, so you can see that most of Apollo Marine Park is sand, but there is quite a bit of rocky reef, especially up in that northwest area, and also lots of sponges, even in the coarse sediment. So the next thing my PhD student did was to use that habitat information from the AUVs to create habitat maps of Apollo Marine Park, and did that by driving a bunch of variables from the bathy and the backscatter, combining that all into a random forest, which is a modeling procedure, and that produced these habitat maps. There's not a ton of going on. There's not a lot of variability in Apollo Marine Park because of the dominance of the sediment. But this just gives us an idea of where the invertebrate reefs are and where the sediment habitats are. And so this is just zoomed in areas so you can see the detail that we get from these habitat maps. And then once we had that, very slow, we wanted to see what the fish communities were down there. So we have these baited remote underwater video stations. You can see it in the upper right. They're like little landers that we put onto the seafloor, and that's a bait bag in the front, and it attracts the fish so that we can get an idea of what fish species are in the area, and also rock lobster really like it, so we get a lot of those. And so we'll go through a couple different habitats. In this map on the right, you can see all the different areas within Apollo Marine Park that we sampled. See a gummy shark. Lots of leather jackets. And then you can also see these really nice sponge reefs. Some rays. And so these are some images of the different fish communities we saw. And you can see that they change depending on the type of habitat you're in. So you get the more reef-associated fishes in the sponge communities. And then as you move into the deeper, more sediment-dominated, we were seeing lots of sharks and cephalopods or cuttlefish. And so we can combine that with the habitat information and look at how the communities are distributed. So the dark brown represents the reef communities, and these are just plots that groups like things together. And so the reef communities are supporting similar habitats compared to the sediment, which we would expect. Next slide. Here we go. And then we can make these types of maps to look at things like, so when we do the baited remote underwater video stations, we count all the fish and go back. We count all the fish, and we can also size them because we have two cameras that create stereo imagery, so we can take the lengths of them, and that gives us information about like species richness, which you see on the left. So the bigger the circle, the more species we found in that particular area. And then also, this is abundance on the right. So the total number of individuals that we saw on each of those bruvs. And then we can use that along with the habitat data to create distribution maps. So this is one for snapper. So you can see that it's found more in the shallower areas, more rocky reef associated, whereas the spiky dogfish, which is a type of shark, is found more in the low relief sediment areas. And one thing that we found were 30% of the observations across the park were of sharks and rays, which is, we usually get about 15%. So there's quite a bit more sharks and rays within the Apollo Marine Park than we would normally expect along this coast. And we're also seeing differences in the associations with the different substrates. So the sharks are more found in the sediment areas, whereas the rays are found in the rocky reef. And then we also did some southern rock lobster surveys to see how they're distributed within the park. And the larger the circle, the more individuals we caught. And this is using baited pots, so fishery methods. And just sampled, went out with the lobster fishermen and they fished where they normally would so that we could see where the lobsters are and how many were there. And then now we're continuing our research in Apollo Marine Park. We've been doing this since 2018, and we're looking at artificial reefs and to see if we can get some information about the sponge communities and how they colonize areas. So we've put reefs, they're called concrete mattresses, and we've put those in about 80 meters depth, and then we go and we monitor them to see how the sponges are colonizing them to get an idea, because there's not a lot known about sponges. They're not the cute animals that you normally hear about. And so this is our design. So we have 4 different sites, and we've put about 64 of these concrete mattresses within this area. And we've also laid down limestone and shell to see if the sponges also recruit to those substrates. And then we're using ROVs and AUVs. So this is our remotely operated vehicle. So the difference is we control this with a little controller and drive it from the boat. And then we can create these 3D imagery of the sponges and look at volumetrics change in the sponges through time. And then I just wanted to go through some of the cultural work we're doing with the Eastern Mar. And this is a Esri story map that we're putting together using what we know about the marine environment and working with them to come up with the cultural values across their sea country. And hopefully this will be live soon so that everyone can visit and learn more about it. But it's just all these pages that tell you about the environment and their connection to it. So just covering different topics. And then this is one thing we did was looking at the past sea level, because a lot of this area was actually above water 30 to 17,000 years ago. So there was actually a connection between Tasmania and this Cape Otway area through the Apollo Marine Park. And when you look at the bathy data, you can actually see the shorelines, the ancient shorelines from when it was above water. And so that's 15,000 years ago, so you can see the water coming in. And then just the species of importance to them. That's all.
Any questions for Mary? That was so cool to see what's going on underwater. Yeah, they do that every time, man. They just like, I swear to God, you're getting off the hook.
Yeah. Just run faster.
Thanks, Jack. Great presentation.
Thank you.
Thank you. Did you find any interesting structures outside the current marine park that we should also be aware of?
Current structures?
Well, the sponge beds are pretty stunning that we're seeing, and the marine park was probably defined without that knowledge. And we're just wondering what else might be out there.
Yeah, I think, well, before we mapped it with our multi-beam, that we didn't really know about those really high relief shoreline, what are ancient shorelines across there. So I guess those were what were discovered through that. And then just they're supporting huge communities of sponges that we didn't know were down there.
Thank you.
Yeah.